In this lesson, we will solve a classic thermodynamics example and visualize it. 1 mole of an ideal gas expands isothermally at 298 Kelvin until its volume is tripled. We will find delta S sub gas and delta S sub total for the reversible expansion case. Here are the givens. To build intuition, let's visualize the expansion with a piston cylinder. We sketch a cylinder with a movable piston. The blue region is the gas. Because the process is isothermal, the gas is in contact with a large thermal reservoir at 298 Kelvin. Heat flows in to keep the temperature constant, while the gas does work as it expands. Now watch the piston move up as the gas volume increases by a factor of 3. Now for the calculation. In an isothermal process for an ideal gas, the change in entropy of the gas is delta S sub gas equals the integral of dq rev over T, which simplifies to n r times the natural log of V2 over V1. We will write that down. Next, we substitute our numbers. N equals 1, R equals 8.314 joules per mole Kelvin, and V2 over V1 equals 3. So delta S sub gas equals 8.314 times the natural log of 3, which is about 1.099, giving approximately 9.13 joules per Kelvin. For a reversible process, the surroundings are a large thermal reservoir at the same temperature. Heat leaving or entering that reservoir gives delta S sub surroundings equal to negative delta S sub gas, since Q sub surroundings equals negative Q subsystem and the temperature is constant. We write delta S sub surroundings equals negative 9.13 joules per Kelvin. Therefore, delta S sub total equals delta S sub gas plus delta S sub surroundings equals 0, as expected for a reversible process. Let's also see the process on a pressure volume diagram. An isotherm for an ideal gas follows P equals constant divided by V. We plot pressure as the vertical axis and volume as the horizontal axis. Here is a decreasing hyperbola, the isotherm. We mark the initial volume V1 and the final volume 3V1. The system moves along this curve during the reversible isothermal expansion. Summary: delta S sub gas equals N R times the natural log of V2 over V1, which here is approximately 9.13 joules per Kelvin. For a reversible process with a constant temperature reservoir, delta S sub surroundings equals the negative of delta S sub gas. Therefore, delta S sub total equals 0. This matches the principle that entropy production is 0 for a perfectly reversible process.